All right, today's lesson is 6.6, scale drawings, pre-algebra. Example number 1. You've already gotten your vocab written. Go back and look at your vocab. A scale drawing is a two-dimensional drawing that is similar to the object it represents. So what you draw on paper. That would be a scale drawing. Maps, two-dimensional. A scale model is when you see architects that are going to build a big building and then they'll build this little scale model to scale. That's a 3D model. So that's the difference between a drawing and a model. And then your scale is what gives the relationship between the drawing or the model's dimensions. So is it like on a map, 1 inch is to 100 miles. That would be a scale. That's what they refer to. All right. On a map, the distance between two cities is 3 inches. What is the actual distance in miles between the two cities if the map's scale is 1 inch to 125 miles? What are we going to do? What have we been doing in this chapter? What are we going to set up? Excellent. Proportion. And actually, I like the boxes on the proportions here today. So what do we know? Let's set that up first. What do we know? We know 1 inch is equal to 125 miles on a map. So we have inches over miles. What's the other thing I know from that word problem? 3 inches.
Yeah, 3 inches.
So they want to know if there's 3 inches between these two cities, say from here to, this is kind of enlarged, it would have to be like way over here on to Bismarck. If there was 3 inches between these cities, do I put 3 inches on the top or do I put it on the bottom?
Top.
It will be my numerator, so 3 inches, because I have inches on the top here, so it's going to have to go on the top here. What goes down here then?
X.
X. That's what we need to solve for. We need to find out X miles. Do our cross products. I like to start with my variable. 1 times X. Well, that's pretty easy. What's 1 times X?
X.
Excellent. 1X or just X. Either one works. Equals, what's 125 times 3? So X equals 375 what? Miles, not inches. We just solved for miles underneath here. So it equals 375 miles would be the distance. All right, checkpoint. On this map, the distance, so set up your proportion. And let's put in the things that we know. The distance between two cities here is 4 inches. What is the actual distance in miles between the two cities if the map's scale is 1 inch to 80 miles? What should the first ratio, what should the first part of my proportion be?
1 over 80.
Okay, 1 over 80 equals
4 over X.
4 over X or X over 4? 4 over X. Well, let's see. This 1 stands for what? 1 inch. This 80 stands for miles. So I have to have inches on the top. Is this 4 referring to inches? Yes, it is. So we know we have it set up right. Inches, inches. Could I have this turned around and go 80 over 1 equals X over 4?
Yeah.
That would work also. All right, now do your cross products. X equals, what's 80 times 4?
320.
320 what? Miles. Questions? Pretty simple. How many of you have already learned how to do this in social studies? That's what I was hoping. Good, good, excellent. Example number Number 2, finding the scale of a drawing. So in a scale drawing, a wall is 2 inches long. Now this is on a drawing, just on the paper. The actual wall in real life is 12 feet long. What is the scale they used on their drawing? Write a ratio using corresponding side lengths of the scale drawing and the actual wall. Then simplify the ratio so that the numerator is always what? Look back at the ones we just did. What is our numerator always?
1.
What is it in this one?
1.
1. So you always, when you want your scale drawing, we want our numerator to be 1. What do we know? We know that 2 inches equals 12 feet. Simplified, what are you going to divide by? 2. So simplified, that equals 1 inch to 6 feet. So our scale of that drawing is 1 inch to 6 feet. What's the other 2 ways? Who remembers the other 2 ways that I could write? Actually, there's only one more way. I can write my ratios like this. I can write my ratios like this. What's the third one that's missing?
1 and 2.
What do you mean? The number 1?
And then 1 and 2. 1 and 2.
Excellent. And the word 2?
And 6.
6. And then we got to have 1 inch to 6 feet. And why do I have to label these? Why can't I just go 1 to 6?
Because you won't know, like, if it's feet, centimeters, or inches.
Exactly. Otherwise, I won't know, like she said, is it feet? Is it centimeters? Is it inches? We don't know. So when they're different, this one is inches to feet. When they're different, we have to label them. They always have to have the labels. So now that takes me to this example. When you read this, it says the scale of a scale drawing or scale model can be written without units, without labels, if the measurements have the same unit or the same label. So if they're both inches, 1 inches to 6 inches, then you can just go 1 to 6. For example, if the scale is 1 centimeter to 2 meters, well, 1 centimeter to 2 meters, I have to label it in that case because they're different. I have centimeters and meters. But if we convert the meters to centimeters, you guys remember how to do that? 2 meters, kangaroos hopping down mountains drinking chocolate milk. How many times do you have to move the decimal to change meters into centimeters? Meters to centimeters is 2 to the
Right.
2 to the right. So that's how they came up with 200. So we have 1 centimeter is to 200 centimeters. Now we have the same label. Then you can write your ratio without labels because they're the same. They're both centimeters, so you can just go 1 is to 200 because they're the same unit, same label. Now let's read the problem. Has anybody ever been to the Sears Tower in Chicago? A couple of you. I've never been there. I heard it's pretty awesome. Is it pretty awesome? So a model of the Sears Tower in Chicago has a scale of 1 to 103. The height of the Sears Tower's observation deck is about 412 meters. Find the height of the observation deck of the model. So, first of all, see this little picture here? They're talking about the observation deck. So for those of you that were there, which part of this is the observation deck? This? Because they say the height of the Sears Tower observation deck is about 412 meters. Is this the observation deck right here? What are they talking about for those that have been to the Sears Tower? Do I have it right or wrong? Or are they talking from, is this the observation deck? Are they saying how high it is from the ground then and up here?
Well, the observation deck is right there where you have that fold line, so I don't know if they're talking about how high it is up or.
So we're going to assume that when they say the Sears Tower that the, whoops, this is the second problem, that the height of it, that must be 412 meters up. Did you assume that's what they're getting at? So from the ground up, you're 412 meters. Let's see if that makes sense. If we have the right spot on the picture here. Write a proportion using the scale. Well, what do we know? We know 1 is to 103, and we're talking what? Since there's no label here, we know they're talking meters. So we know equals, where does 112 go? Top or bottom? Bottom, because it's 103 meters. If it's 412 meters, how many meters is our scale model? Now this is the actual 3D model they're making. So now what do I get? I get 103x equals 412 divide by 103. What does x equal, class?
4.
Exactly 4. And we're talking 4 what? We're talking meters. So on a scale drawing, 4 meters, would this be a pretty big scale drawing? Because if you look at the screen here, now if you're watching this on TV, it's going to be pretty small, but the length of my active board here is probably about a meter. All right, my active board is about a meter. So in a real 3D scale model, have 4 of those together, but it is isn't it the tallest building or one of the tallest buildings in the world, right? Would that be about right then in a model, a 3D model? That'd be a pretty big model, but it'd be pretty cool. So we are assuming that it is from here to here. That's how tall it is, 400. So you'd have to have 412 of my active boards stacked up on top of each other just to get up to the observation deck. So does that seem about right? I think our guess was probably right then, don't you? From here to here? Now let's figure out this one. Okay, again, what do I know from the previous page? In our model. Our 3D model is 1 to what? 103. And what do we know here? They're telling us the height of the antenna. Right here. This antenna is about 521.1 meters. So then is our assumption right on the height of the observation deck? Who says yes? Raise your hand. Who says no? We're not sure. We're about half and half. So let's keep going to see if we're right. Do we still think that this should be the observation deck? And if the antenna is 521.1, let's figure this out. So we put 521.1 here. What goes up here?
X.
Good. All right, now let's solve this. 103x equals 521.1. Divide by 103. What does x equal? 5 rounded to the nearest tenth.
1.
5.1. Okay, so the scale for the antenna is 1 to about, let's round it to the nearest whole number, 5.
Yeah.
So our scale is 5 to 1, or excuse me, 1 to 5. What was the scale for this?
4.
1 to 4.
Now let's vote again. If this is 521.1 meters, is this 412 meters? Do we agree with that? Is this there? What we're saying here then is that this is 521 and this is 412. Is that right? No. So this must not be what they're talking about on the observation deck. What are they talking about then? It's not this part. It is the what? Was it the original one that we talked about? Does this seem about right? We talking about that part of it? Does that seem to be about 412? Would that be more realistic? We have our antenna here in our observation deck. Is that a little closer? Right. Now, what do we see wrong with this? Because we figured out this scale as being 1 to 5. This part was 1 to, what did we figure out? This one was 1 to 4. In a real life model, what is wrong with that, if that's how they did the scale? Maybe it could fall over, true, but there's a glitch here. Shouldn't it be the same? Absolutely. Because otherwise your scale model isn't accurate. If you have a scale, if you're doing 1 to 4, you need to do your whole model 1 to 4. If you're doing it 1 to 5, then the whole thing has to be 1 to 5. Otherwise it's going to be distorted and it doesn't give you the actual scale to what it would look like. It'll be distorted. Now when we do our scale drawings tomorrow, just think if you did part of your scale drawings 1 to 1 inch or 1 centimeter to 1 inch, and then you just decided to do, oh, let's do the rest of it 1 centimeter to 2 inches. We wouldn't be doing scale drawings, we'd end up with caricatures. You know what those are? Distorted, funny pictures, all right? It would look like you're looking in one of those haunted house mirrors. It wouldn't be a true scale drawing. So when you do a scale model or a scale drawing, you're going to want to use the same scale on the whole thing. Think of a map. If you did part of this map, 1 inch equals 200 miles. Oh, but on this part of the map, 1 inch equals 400 miles. Is that going to work? No. All right, so good examples there. Your assignment, I want you to do the worksheet 6.6. That's due tomorrow. You'll work on that. After you finish the quiz, I'm going to hand out a quiz on 6.1 to 6.5. This is open note. You may use your notes and your calculator.